As we have seen in the module 1, we have just discussed about the semiconductor diodes and applications. And in that semiconductor diodes and applications, we have just seen from the scratch about the PN junction diode up to the LEDs or the photocoupler. Now, just moving to a little different advanced level, that is in module 2. Okay, till now what we had discussed was module 1. In the module 2, here I just brief you about the module 2 contents. In the module 2 contents, here overall module 2, what it contains is here about the FETs and the ACRs. FET means is a field effect transistor. In that, I had mentioned the JFET, that is a junction field effect transistors and silicon controlled rectifiers. These are the ACRs. Okay, so this is two different parts where we have to learn about the FETs and it's a ACR, where ACR is the extended version of the FET. In the FET, we are here going to see from the scratch how it is being connected from the basic construction level up to its characteristics. Okay, of course, the structure and the symbol all will come into the picture. Okay, next, after seeing that how we are going to see the characteristics, how it behaves with respect to the voltage and the current levels. Okay, next, we'll go slowly move on to the silicon controlled rectifier, that is called as ACR. It's the extended version of your FET, and in this ACR we are going to see how we can see the true two transistor model, TWO2 transistor model, and the switching action characteristics, and of course the applications for both JFET and the ACR. Now, this is the overall picture of your module 2 contents. In this module 2 contents, in that first session, we are going to see just about the JFET. Okay, JFET. We'll see the introduction, basis of JFET, constructions of JFET, and the standard notation in JFET, of course, the symbols along with the symbols. Okay, now coming on to the introduction to JFET. First of all, field effect transistor is called as FET, whereas JFET means is a junction field effect transistor. It is widely used in all the electronic circuits. This JFET is a reliable and a useful electronic component that can be used very easily in a variety of electronic applications where all we use in a day-to-day life, along with the switching actions. Okay, and we can say that this is freely available also. These JFETs are freely available also. Since I told it is having a switching operation, so it means that it can be used as electronically controlled switch. JFET is one of the type of a FET transistor, and it can be used as the switching controlled operation. That means it can be used as electronically controlled switches. Okay, as well as it also can be used as voltage controlled resistors as and also as an amplifier. Okay, now JFET transistors is very reliable. Why? Because here it is used from many years, because it gives a good balance between the cost and the performance, which is very much useful for our day-to-day life. Okay, why I say it is reliable means it doesn't exceed the high levels of your DC input resistance. Okay, so I tell it is very reliable, robust, and very easy to use. This all characters makes an ideal choice for many electronic circuit designs. So I can tell it is freely available. Hence, JFET can be freely available and it is very easy to use. And I tell also we can tell that the FET consists of a section of a silicon whose conductance is controlled by an electric field. Okay, this is the continuation of the introduction part. If I tell electric field means here it has got E plane and a H plane as we had discussed in module 1. E plane means the electric field, H plane means the magnetic field, and it can be used in different types of modes. Okay, now this JFET basically consists of a section of a silicon whose conductance is controlled by an electric field. The section of a silicon through which the current flows is called as a channel. I repeat, the section of a silicon in which the current flows is called as a channel, and it consists of a mixed type of silicons also, and it consists of only one type of silicon, either N type or P type at a particular type. Okay, how do you differentiate between N type and P type? We'll just see in the next further coming slide about our symbol, how they are represented in terms of the symbol. Now, in this channel, I was telling you, it consists of either N type or a P type. Okay. Now, the connections are either end of the devices are called as source and drain. The electric field to control the current is applied to the third electrode known as a gate. Hence, we have three layers like source, drain and gate. Okay, these are called as the three terminals. These are called as the three terminals, namely source, drain and gate. As it is only the electric field is being applied and it controls the current flow in the channel, the device is said to be voltage operated. Hence, we can say that JFET are voltage controlled devices. If it is having a voltage controlled devices, it has very high input impedance. Very high in the sense, usually the range, it can be in mega ohms. Okay, and this can be a distinct advantage over the bipolar transistor, where we have seen about the bipolar transistor in our module 1. And whereas bipolar transistor, there if you remember, I told it's a current controlled or the current operated device, whereas your FET is a voltage operated device. Okay, because it is having only the electric field that controls the current flow in the channel, the JFET is said to be voltage operated. Now, as we have learnt in module 1 about the BJT or the bipolar junction transistor, here we have JFET also. Just for an easier understanding, just compared between the BJT and a FET. In this, here we can see, as we have discussed in module 1, the symbol of an BJT for an NPN transistor is this, whereas for an PNP transistor is this. In the similar fashion, we can have N type or the N channel, P type or the P channel. Hence, we have two types of a JFET named as N and a P. Okay. Now, in BJT, when we have just briefly compared here, regarding the symbol, we have seen if at the emitter, we have already seen the module 1, if at the emitter, if this arrow mark is pointing out, then I tell it is a NPN. In the similar fashion, here, if this arrow, that is a middle arrow, then it is a N type. The terminals of a BJT are collector, base and emitter, whereas the terminals for an JFET are drain, gate and source. Okay, so and the differentiation between the N and a P type channel in a JFET is with respect to the gate, where the arrow mark you can just observe here, it is going inside and here it is coming out. Similarly, we had already compared between the NPN and a PNP with respect to your BJT. So this is NPN type of transistor, whereas this is PNP type of transistor. These two are related, and it has been symbolized in your bipolar junction transistor. Coming to JFET, these two, N channel and P channel, are symbolized and is being related to our FET or JFET, okay, junction field effect transistor. Now, this is just the comparison between the BJT and the FET we have seen. Coming to the constructional part. Construction here, it is here, the basic construction is very simple structure. Okay, why? Because if this is a N channel JFET, the N type silicon bar is present. A N type silicon bar is present, as we can see in this diagram. See, N and N. Okay, this is for a N channel FET, and for a P type, here it is P channel and P channel, where among all these types, these two types, you can pop out the three terminals, namely drain, gate and source. The gate forms the middle terminal, whereas the other end-to-end terminal forms the drain and the source. This is for a N-channel JFET. Okay. Similarly, for a P-channel JFET, the end-to-end are P and the terminals are drain and source respectively. Whereas the middle layer called as N, we can pop out or we can pull out the gate terminal. Coming to the representation of this construction, we can see here about the drain, gate and the source. You can see that there are two gates. P-type gates are two at the end to end. It has been sandwiched. It means that here you can consider like a cylinder, where at the middle of the cylinder there is something which has been pasted. So that is called as a P-type. P-type. Whereas in between there is a N-type. Hence the channel is N-type, whereas at the side where we have pasted is the P-type, and that from the P-type you're going to pull out the gates. Hence we can have like the connection of two P-type to a common gate, as we have seen here. Okay, this is for N channel because the channel path is N. Whereas coming into the P-type, here the channel path is P. If the channel path is P, here at the sides we have the N. Okay, this is just the basic construction. This is just the basic construction of our N channel and a P channel. Now, what is the silicon? This middle silicon behaves. The silicon bar which is present here, as we can see, behaves like a resistor between the two terminals, between the extreme two terminals, namely drain and source, D and S. So silicon bar behaves like a resistor between its two terminals, drain and source. The gate terminal is analog to the base of the ordinary BJT. It is used to control the flow of current from source to drain. Remember, this silicon bar here in between you take out the gate, and this one is used to control the gate terminal, is used to control the flow of current from source to drain. Thus, source and drain terminals are analog to or similar to the emitter and the collector terminals respectively compared with BJT. In this figure, we see there is a P region or the P channel for a JFET. Okay, while the other two terminals are drain and source. So similarly, here in this N, in this here P channel, in this P channel here, it behaves like, again, the silicon bar behaves like a resistor. Okay, since JFET is a silicon device, it takes only 0.7 volts. In BJT, we have already discussed that germanium means 0.3 volts, silicon means 0.7 volts. Similarly here, since the middle bar is of a silicon, here the JFET is a silicon device, and hence it takes only 0.7 volts for what? For forward bias to get significant current in the terminals. Okay, so here is a pictorial representation we have seen. Now, if the gate terminal not connected, then the potential, that is, potential means is any voltage applied. Here, the current is called as a drain current. Understood? If there is no voltage applied at the gate, then only there exists a drain current. Drain current is I suffix T, that is flowing through the channel located between P regions. These two P regions. Okay, this current consists only one majority carriers, that is electrons. Only one majority carriers, that is electrons. In this case, in P channel, here we are seeing the P channel JFET. Here there is only one. It is similar construction of your N channel, except the P type semiconductor between the N. So it consists only one majority carriers, that is namely holes. So for a N channel, the majority carriers are electrons, whereas for P channel, the majority carriers are holes. Okay, because we have already seen in a NPN and a PNP in a BJT that the majority carriers for NPN are electrons, whereas for PNP is of holes. Okay, so this forms a basic construction of our JFET. The same thing, whatever I have told now, I just wanted to symbolize in a schematic diagram of a N channel and a P channel. Means, as I've already seen here, as I've already told you, the three terminals are gate, drain and source. Gate is G, drain is D, S is source. Irrespective of any type of channel, this three terminals are fixed. The middle layer is always little bit thick because of the silicon bar present in the gate terminal. As we have seen in this above diagram, here in the middle layer there is a silicon bar, and there only we are going to pull out gate. Similarly, here in the representation also. Only the difference in schematic symbol in JFET is of the arrow mark. Where in a N channel JFET at the gate terminal, the arrow mark goes inside, whereas this is coming outside. This is the general schematic symbol of the JFET for a N channel and for a P channel. Coming next to the notations. We were talking about something called as channel, something called as D, G and S. Let us see in detail what does this channel do, D, G and S do. As I have already told you, S means source, D means gate, and G means gate, D is drain, S is source. Channel means is a region between the source and the drain, and it is sandwiched between the two gates. It's called as a channel. Whereas S means source, that source terminal is termed only when the majority carriers enters the channel. Whereas in the drain terminal, the majority carriers will leave the channel. Gate are two internally connected heavily doped impurity regions formed by alloying or by diffusion or by any other method available to create two p-n junctions. These impurities regions is called as a gate. Gate is represented in the symbolic notation as G and is always present as a metal layer where it contains a silicon bar. In this drain terminal here, conventionally the current is leaving the channel and is designated as ID. I means for current, D suffix D is for drain. Similarly, in a source also, the conventional current is entering the channel at S and is designated as IS. I represented for current, S suffix is represented for source. So we have the current entering the channel as IS, the current leaving the channel as ID, respectively for the source and the drain. And coming to the gate, here a voltage is applied between source and the gate, and that voltage is called as VGS. When the voltage is applied between the source and the gate, that particular voltage is called as V suffix GS. Okay, and in this, it acts whether the PN junction is forward biased or the reverse biased. Okay, conventionally here the current is entering into the channel at G and is designated as IG. Hence it is called as a gate current. Okay, the channel means it is a path where the current can flow only when the JFET is activated. The region between the source and the drain is sandwiched between the two gate terminals is called as a channel, as I have told you, and the majority carriers always moves from source to drain through this channel. Note that the direction of the arrow of the gate here, the direction of the arrow of the gate represents or indicates the direction in which the gate current is flowing when the gate junction is forward biased. Thus, for N-channel JFET, the arrow at the gate junction points into the device, because for an N-channel JFET, the current flows into the gate only when the VGS terminal voltage between gate and source terminal is being energized or being applied. Whereas in this we see that for a P-channel JFET, the current flows outside the gate. It means that whenever there is a voltage energized between the source and the gate, the current leaves the gate terminal. This is a schematic symbol in JFET and these other notations where we have seen. Thank you.